Okay, so this is problem 133, clone graph. Given a reference of a node in a connected undirected graph, return a decopy clone of the graph. Each node contains a value in a list of its neighbors. For test case format, for simplicity, assume each node's value is the same as the node's index. So it's one indexed. For example, the first node with value 1, second node with value 2, and so on. The graph is represented in the test case using an adjacency list, which is a collection of unordered lists used to represent a finite graph. Each list describes the set of neighbors of a node in the graph. The given node will always be the first node with value 1, and it's returned a copy of the given node as a reference to the clone of the graph. Okay, so you basically get an adjacency list, and node 1 is going to have neighbors 2 and 4. Node 2 is going to have neighbors 1 and 3, and then so on. And you're just going to return a clone of this. So here, this is not, you don't want to return the exact same nodes and its neighbors. Here, you create a clone of each node, and then, so the graph, the nodes they're all new. The graph looks the same, but it's actually a new graph. So that's how you return this. Here, the neighbors are not the same because node 1 has neighbor 3, whereas here it's supposed to be 4 and 2. So if you look at some other examples, here you got node 1 that has no neighbors. So that's why the output is just going to be an empty list for the fact that the clone will not have any neighbors. Here, there's no nodes at all. So that's why you just return an empty list. Okay, so first thing that we're going to need is, since we're creating a clone of each node, as we're iterating through this graph, it will help to have like a dictionary to keep track of which nodes already have their clones have already been created. So for example, if we start with node 1, we're going to create a clone of it. So then we'll have a dictionary, a key value mapping of the original node with the clone of it is 1. And the reason this is necessary so that, when we go to 2, we look at its neighbor, we're going to go back to the 1. We don't want to create the clone of 1 since it was already created. So we can just extract it from the graph or the dictionary. So we're going to have a self.dict equals an empty dictionary. See. If node not in self.dict, then clone would be the self.dict, or you create a new node, which would be node.val, and then for neighbor in node.neighbors. So we can have this clone graph return the clone of the node. So we could say then that clone.neighbors, you would append the clone of the neighbor. And then now here we're going to return the clone. And then we have to handle the case where the node already is in the dictionary. So then clone would just be self.dict of node. And then here we got to make sure to add the clone to the dictionary. So self.dict of node equals clone. And that should do it, except for one thing, is that when we call the clone graph, we're going to have the dictionary to be empty each time. So we won't want that. We want to reuse the same dictionary for each time we call clone graph. So it would be better to have like a constructor out here. This would store the dictionary. And then we just reuse this dictionary each time clone graph is called. Okay, so that should handle this case. It should handle this where you create the clone. It's not going to have any neighbors, so you just return a clone. But in here, node, it doesn't even contain the node, or node is just none. So then if node is none, just return none. And that should do it. And it passes all test cases. So that's it. Thank you very much for watching this video.